Hey everyone, Stelvio here. Welcome back to the channel where we break down data architecture and everything in between. If you are into database and tech, make sure to hit that subscribe button here below, like this video, and share with your datamates. Today we are diving into the world of databases, but not just any databases. Look at that. There are so many types, relational, graph, time series, NoSQL, vector, blockchain, and more. But what do they all mean? And more importantly, when should you use one over another? Stick around and we unpack all the different kind of databases, explore real-world use cases, and help you to choose the right tool for your data-driven solution. Let's go. Let's move on to the vector database. What exactly is a vector database? Unlike traditional databases, vector databases are optimized for storing and querying high dimensional vector data. But what does that mean? Vectors are essentially a way to represent data in a multidimensional space. Imagine you are dealing with complex information like images, text, or even sounds. Each piece of data can be transformed into vector, which helps computers understand similarities between them. For example, two similar images or two similar phrases or two similar phrases will have a vector that are closer together in this multidimensional space. Vector databases are useful in machine learning and AI ML applications. They are perfect for tasks like similarity search, where you want to find data points that are similar to each other. For example, if you have a recommendation system, vector database can help find similar products or movies based on user preferences. They are also used in natural language processing, NLP, like understanding word embeddings or text similarity. Vector database can store the vector representations of word or sentences and help in retrieving the most similar ones based on meaning. You can find mentioned here some of the popular example of vector databases. A great example of famous application that uses a vector database is Spotify. If you ever noticed how Spotify Discover Weekly feature suggests songs you might love, that's powered by vector databases. Spotify uses vector representation of songs based on things like mood, tempo, and more, and store them in a vector database. When you listen to a song, Spotify search for other songs with similar vectors, helping it recommend music you will enjoy. So to sum up, vector databases are essentially for handling high-dimensional data, making them ideal for use cases in machine learning, recommendation system, and NLP tasks. They power applications like Spotify and many others that rely on understanding the similarity between data points. All right, are you still with me? Let's talk about in-memory databases. These are all about speed. Let's take a look. What exactly is an in-memory database? Well, these are databases designed to store data in RAM, random access memory, rather than on traditional hard drives or SSD. The big advantage here is exactly speed, since data in RAM can be accessed much faster than data stores in this on disk. When data is stored in RAM, the access time is almost instantaneous. This makes in-memory database perfect for use cases where you need extremely fast data storage and retrieval. In-memory databases are commonly used in situations like caching, for instance. Caching is when you temporarily store frequently accessed data so that it can be retrieved quickly. Thinking when you are browsing the web and your browser load the page fast because it's already cached. They are also widely used in session management, where data about the user session, like their login state, for instance, needs to be retrieved instantly. And real-time application, of course, such as gaming or financial trading platforms, where low latency is critical and every millisecond counts. Some of the most well-known in-memory databases are Redis, for instance, and Memcached. Both of these are designed to provide fast data storage and retrieval by keeping the data in memory. A famous example of an application that relies heavily on in-memory databases is Instagram, especially when you are quickly scroll between posts or load images. That's partially thanks to Redis. Instagram uses Redis to cache images, user session data, and frequently accessed content, assuring that it loads nearly instantaneously for millions of users around the world. So to recap, in-memory databases are all about speed, which is crucial for applications like caching, session management, and real-time processing. Popular examples include Redis and Memcached, and popular example includes apps like Instagram. Alright, and what about multimodal databases? What exactly is a multimodal database? A multimodal database allows you to storage and manage multiple data types, like for instance document, graph, or key value, all within a single system. So this gives you the flexibility to work with different data models depending on your application needs. For example, you might need to store structured data in a key value store, semi-structured data in a document model, and connected data in a graph model, all in one place. Rather than using different database for each data type, a multimodal database allows you to manage everything in one unified system. Why this is useful? Well, multimodal databases are perfect for application that needs to handle different types of data together. Think about application in social media, for instance, a recommendation system or content management, where you might need to store user profiles, relations between users, and content like images or posts, all mm, in one database. Some particular examples of multimodal databases includes ArangoDB, OrientedDB. These databases allow you to mix and match different data models to suit your specific needs, making them very flexible for developers. A great example of a famous application that uses a multimodal database is eBay. eBay handles a wide range of data types, product listing, user profiles, buying histories, and seller relationships. With all these different data needs, a multimodal database allows eBay to store and query the data efficiently. So to recap, multimodal databases are powerful because they let you store and manage multiple types of data, document, graph, and key value, all in a single system. This flexibility is especially useful for applications that need to handle diverse datasets like eBay and other complex platforms. And that's wrap on today. Dive into databases. I hope you find this breakdown helpful. If you enjoyed this video, don't forget to hit the like button, subscribe, and turn on the notification bell. Also, let me know in the comment section down below what's your favorite database. Thanks for watching, and I'll see you in the next one. Stay curious, keep learning.